Circular motion. All right? To go in a circle, you have to be pulled towards the middle of that circle. Right? So if you ride a merry-go-round, you're going around in a merry-go-round, you feel like you're going to be flying off to the side. All right? That's because you're being pulled to the middle of the circle. So if I want to spin this in a circle, I have to pull it towards me because I'm the center of the circle. All right? And that's circular motion. We call that pulling towards the center centripetal force. Okay? And so you can do real cool tricks with that. As you're going to see, I'm going to take this little platform here and put some water on it and make it go in a circle. Got it on the table here. And now I have to pull it towards the center of the circle, and it will go in a circle. All right, so here we go. 360 degrees, upside down, amazing cup of green water. Now, why did this work? So, when this was traveling in a circle, remember, it was being pulled towards my finger. Well, really only the platform was being pulled towards my hand. Okay? And so what was causing this to go towards my hand? Well, the platform was pushing on the cup. Okay? So I pulled on the platform pushed on the cup, so the cup felt like the platform was pushing up on it. Just like when I'm standing here on the earth, I feel like the earth is pushing up on me, supporting me, because really gravity, the ground is pushing up on me because gravity is pulling me down. So I feel like I'm just standing here. So this thing sort of had artificial gravity when it round in a circle. So now let's see what happens when we use this idea of centripetal force in a couple cool examples.
So now we're going to do a demonstration that's pretty hard to do visually for you, but we're going to try it anyway because it's really cool. I have a lit candle right here, as long as I don't burn my finger. All right? And I'm going to spin it in a circle. And we all know that the flame of a candle goes upwards because hot air kind of rises. Well, what we're going to do is we're going to kind of artificial gravity here because we're going to spin this around, remember, and we're going to spin it in a circle, and it's going to go around fast in a circle. All right? And so what happens is it's going to think that that way is up, towards the middle is up. So if I put this on, this is to keep the candle from blowing out, and spin this really fast, watch where the flame of the candle points. It's pointing just a little bit towards the middle. Let me try one more time. A little hard to see. Here we go. It points towards the middle of the circle because basically what's going on, again, is that all the air inside this bell jar is being pushed on by the bell jar, okay, pushed that way. And so the air kind of flows down this way, and it's as if you have artificial gravity pulling you this way. You're being accelerated that way, just like the Earth is accelerating you. And so the flame will point towards the middle. Now we can do the last cool thing. It's time for the finale, the paper saw. What I have here is a saw made of just normal, everyday paper. All right, you've gotten paper cuts before. Well, we're going to take this paper and use it to cut a piece of wood. That's lightweight wood, but it's still wood. Now, how are we going to do that? Well, if we spin it really fast, remember, it's being pulled towards the middle in order for it to go in a circle. So what happens is this piece of paper is going to become very taut. Right? It's trying to fly out in all directions, but it's being pulled in, and so it's going to be very tight, and it's going to get really stiff, and we can actually cut a piece of wood with a paper saw. There we go. And we have the paper saw cut right there. All right. So, until next time, watch out for paper cuts.